Hari Om. Hello everyone, I am Srijyoti. Welcome back to my channel. In this video, we are going through some case study questions based on probability. First question. A shopkeeper sells three types of flower seeds A1, A2, A3. They are sold in the form of a mixture where the proportions of these seeds are 4:4:2 respectively. The germination rates of the three types of seeds are 45%, 60% and 35% respectively. Based on the above information, solve the following questions. First question, calculate the probability that a randomly chosen seed will germinate. There are three types of seeds, A1, A2 and A3. We have the ratio A1 is to A2 is to A3 is equal to 4:4:2. That is, what is probability of A1? Probability of A1 is 4 out of 10, right? 4 out of 10. Probability of A2 is equal to 4 out of 10 and probability of A3 is equal to 2 out of 10. Right? Now here, what we have to find? We have to find the probability that a randomly chosen seed will germinate. So here, let's take the event E. E be the event that a seed will germinate. A seed will germinate. Okay. Now what we have to find here? Here we have to find probability of E. Okay. So what is probability of E given A1? That is, probability of a seed will germinate. It is given that the seed A1. Okay, the seed is A1. So here it is given the germination rates of the three types of seeds are 45%, 60% and 35% respectively. Okay, so here probability of E, that is probability of a seed will germinate, and it is given that the seed is A1. So it is 45%, right? That is 45 divided by 100, right? That is equal to 9 by 20. Okay. So next is probability of E given A2. That is probability of seed will germinate. Okay, probability of a seed will germinate. It is given that the seed is A2. Okay, so it is given that is 60%, right? Probability of E given A2 is 60%, that is 60 divided by 100. That is 6 by 10, 3 by 5, right? Next is probability of E given A3. Probability of a seed will germinate. It is given that the seed is A3. Okay. So that is seed is the type of A3. That is 35%. Probability of E given A3 is 35 divided by 100. That is 7 divided by 20. Okay. Now see here what we have to find. We have to find the probability that a randomly chosen seed will germinate. That is, we have to find probability of E. So here, and we have probability of A1, A2, probability of A2, probability of A3 and probability of E given A1, probability of E given A2, probability of E given A3, right? So here, how to find probability of E? We have a formula, that is total probability theorem. Probability of E is equal to probability of A1 into probability of E given A1 plus probability of A2 into probability of E given A2 plus probability of A3 into probability of E given A3. Right? We have all these terms, right? So let's substitute. Probability of A1 is 4 by 10, that is 2 by 5 into probability of E given A1 9 divided by 20 plus probability of A2 4 by 10, that is 2 by 5 2 by 5 into probability of E given A2 3 by 5 plus probability of A3 is 2 by 10, that is 1 by 5, okay, 1 by 5 into probability of E given A3 7 by 20, that is equal to 18 divided by 100 plus 6 divided by 25 plus 7 divided by 100. So let's make it 100, okay. So to make 100, here we have to multiply 4, right. That is equal to 18 plus 6 into 4, 24 plus 7 divided by 100. That is equal to 18 plus 7, 25, 45, 49. 49 divided by 100. Right? So here probability that a randomly chosen seed will germinate is 49 divided by 100. Next we will find the second question. Calculate the probability that the seed is of type A2 given that a randomly chosen seed germinates. That is conditional probability, right? So here we have to find the probability that the seed is of type A2. That is probability of A2 given that randomly chosen seed germinates. That is E, right? So probability of A2 given E. We have to find probability of A2 given E. See here how to find? By Bayes theorem, right? We have a formula, probability of A2 given E is probability of A2 into probability of E given A2, right? Don't be confused. Probability of A2 given E is probability of A2 into probability of E given A2 divided by, there are 3 types, right? So 3 events. Here probability of A1 into probability of E given A1 plus probability of A2 into probability of E given A2 plus probability of A3 into probability of E given A3, right? Now let's substitute the values. Therefore probability of A2 given E is equal to probability of A2 is 2 by 5 into probability of, so let's multiply this itself, okay, so that we can cancel the denominators, right, denominators of numerator and denominators. So here probability of A2 given E is probability of A2 4 by 10 into probability of E given A2, 60 divided by 100 divided by probability of A1 4 by 10 into probability of E given A1 45 by 100 plus probability of A2 4 by 10 into 60 divided by 100 plus probability of A3 2 by 10 into 60 by, probability of E given A3 is 35 by 100. That is equal to, it is 240. See here 100 into 10 in numerator and denominator, this 100 into 10, that is 1000 is cancelled. So next remaining 240 divided by, here 180 plus 240 plus 70, that is equal to 240 divided by 300, 420, 490, right? 490. That is 24 by 49. 24 by 49. Okay. So here probability of the seed is of type A2 given that a randomly chosen seed germinates is 24 divided by 49. Look at the next question. There are 2 anti-aircraft guns named as A and B. The probability is that the shell fired from them hits an airplane are 0.3 and 0.2 respectively. Both of them fired one shell at an airplane at the same time. Based on the above information, solve the following questions. So here, see, first question, what is the probability that the shell fired from exactly one of them hit the plane? So here exactly one of them hit the plane. So there are, see, what are the possibilities? See, one is probability of shell from A hits the plane and B does not hit the plane, because it is given exactly one of them. Okay. If A hits the plane and B does not. Okay. Here next is probability of shell from B hits the plane and A does not. Okay. So here we can write probability of shell fired from exactly one of them hit the plane is equal to probability of, first case is if A hits the plane then B does not, right? So shell from A hits the plane and B does not hit the plane. Okay, next one, plus probability of shell from B hits the plane and A does not. Okay, so here that is equal to, see here, probability of shell from A hits the plane and B does not. That is here multiplication theorem, right? Probability of A intersection B. That is probability of A into probability of B. Right? So here probability of shell from A hits the plane. It is given. What are the probabilities? See here, the probabilities that the shell fired from them hits an airplane are 0.3 and 0.2 respectively. Therefore, here the probability of shell from A hits the plane, that is probability of the shell from A hits the plane is 0.3 and 0.2 is the probability of shell from B hits the plane, right? So here probability of shell from A hits the plane is 0.3 into, because it is and, right? And B does not hit the plane. Here we have probability of B hits the plane is 0.2. If it is the probability of B does not hit the plane, means 1 minus probability of B, that is 1 minus 0.2, that is 0.8, right? Plus, right? Plus, because it is OR, okay? We can write OR. OR means that is union, right? Union with plus, okay? Probability of shell from B hits the plane and A does not hit the plane, right? That is probability of a shell from B hits the plane is 0.2, okay? 0.2 into, here A does not. We have probability of a shell from A hits the plane is 0.3, right? And its complement. A does not means its complement, right? So complement is 1 minus 0.3, that is 0.7. That is equal to 0.24 plus 0.14, that is equal to 0.38. It is the required probability. Second question, if it is known that the shell fired from exactly one of them hit the plane, then what is the probability that it was fired from B? See, look at this one carefully. It is known that, means it is given that. So here we have to find the conditional probability. That is probability that it was fired from B, given that the shell fired from exactly one of them hit the plane. Okay? That is, we have to find probability of shell fired from B hits the plane. Okay. The shell fired from B hits the plane. Given that the shell fired from exactly one of them hit the plane. Okay. It is equal to, that is probability of A given B. We know that probability of A given B is equal to probability of A intersection B divided by probability of B, right? That is, here probability of, see what is the intersection of these two events? Shell fired from B hits the plane, okay, and shell fired from exactly one of them hit the plane. See, what does it mean? That means what is the intersection? So here we can say shell fired from exactly one of them hit the plane, intersection shell fired from B hits the plane. That means shell from only B hits the plane. Okay, shell from only B hits the plane and A does not hit the plane. Okay, so here we can write probability of shell from only B hits the plane, okay, and A does not, okay, because it is given, see our two events and its intersection, that is shell fired from B hits the plane, intersection shell fired from exactly one of them hit the plane. Therefore, the only one possibility is shell fired from only B hit the plane and A does not hit the plane. Okay, so shell from only B hits the plane and A does not hit the plane. Right? Divided by, now it is the intersection of these two events. Okay, divided by probability of A given B is probability of A intersection B divided by probability of B. Right? So what is probability of B? This one, right? Probability of shell fired from exactly one of them hit the plane. Right? Now, see what is the probability of this numerator? Probability of shell from only B hits the plane and A does not hit the plane. Means what is the, that is probability of A intersection probability of B, right? So probability of shell from only B hits the plane is 0.2. Right? So it is the probability of shell from B hits the plane, right? So 0.2 into, see, and, okay, into A does not hit the plane, means and means intersection, right? So A does not hit the plane. Here we have the probability of shell from A hits the plane is 0.3 and A does not hit the plane means its complement, right? That is 1 minus probability of A. That is 0.1 minus 0.3, 0.7 divided by, see this one we have already found in first question, right? That is probability of shell fired from exactly one of them hit the plane. We have got 0.38, right? 0.38. That is equal to 0.14 divided by 0.38. That is equal to 14 divided by 38. That is 7 divided by 19. So here required probability is equal to 7 divided by 19. Look at the next question. In an office, 3 employees, James, Sophia and Oliver, process incoming copies of a certain form. James processes 50% of the forms, Sophia processes 20% and Oliver the remaining 30% of the forms. James has an error rate of 0.06, Sophia has an error rate of 0.04 and Oliver has an error rate of 0.03. These are the questions. Find the probability that Sophia processed the form and committed an error. See, first of all, let's write what are given. See, probability of process of the forms by James is 50%. That is probability of, let's denote it by J. Okay. That is James processes 50% of the forms. So, probability of process of the forms by James is 50%. That is 50 by 100. That is equal to 0.5. Next, probability of process of the forms by Sophia is 20%. That is probability of S is equal to 20 divided by 100. That is 0.2. Next, probability of process of the forms by Oliver is 30%, right? So, probability of O is equal to 30 divided by 100. That is equal to 0.3. And next it is given that James has an error rate of 0.06. So, here let E be an event that committing an error. Okay. So, here it is given committing, that is probability of committing an error rate by James is 0.06. Okay. That is probability of committing an error by James, that is probability of E given J is equal to 0.06. And probability of committing an error by Sophia is 0.04. That is probability of E given S is equal to 0.04. And probability of committing an error by Oliver is 0.03. That is probability of E given O is equal to 0.03. Our first question is, find the probability that Sophia processed the form and committed an error. That is probability of processing of the forms by Sophia. That is probability of S. Right? Probability of Sophia processed the form is nothing but probability of S. And committed an error by Sophia. That is required probability is equal to probability of S into, that is and, okay. Sophia processed the form and committed an error. That is probability of committed an error by Sophia. That is probability of E given S. Right? That is equal to probability of S is 0.2 into probability of E given S is 0.04. That is equal to 0.008. So, required probability is equal to 0.008. Second question, find the total probability of committing an error in processing the form. So, here we have to find the total probability. So, apply total probability theorem. That is, required probability is equal to, that is probability of total probability of committing an error in processing the form. Required probability is equal to probability of J into probability of E given J. Okay. Plus, that is the probability theorem, total probability theorem. Probability of S into probability of E given S. Plus probability of O, right? Probability of O into probability of E given O. Right? Here, that is total probability means James, Sophia and Oliver, all of them processed the form and committed by an error. Okay, all of them processed the probability of, all of them processed the form, that is processed the form by them and committed an error by them. Okay, so that is nothing but total probability theorem. So total probability, that is required probability, is equal to probability of J into probability of E given J plus probability of S into probability of E given S plus probability of O into probability of E given O. That is equal to probability of J is 0.5 into probability of E given J is 0.06 plus 0.2 into 0.04 plus 0.3 into 0.3, right? 0.03. That is equal to here 30, that is 0.03 plus 0.008 plus 0.09, right? 009. That is equal to 0.008, 0.009, sorry, 0.3. 0.03. Okay. 4, 0. Okay. So 0.047. 0.047. So required probability is equal to 0.047.